Let's take a look at 2022, day 7. Day 7, no space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. That's right, we're walking into a jungle. Occasionally you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device Elves gave you has problems with more than just its communication system, which we fixed yesterday. You try to run a system update, please, pretty please with sugar on top, error, no space left on device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output. Ooh. For example, cd ls. Oh, I see what he's doing. That's a directory called A. That's not unusual. That's not a typical ls command. So it's not like a dir. There's a file called dir and a file called A and a file called this number and a file called b.txt. All right, let's read this. File system consists of a tree of files, plain data, and directories which contain other directories or files. The outermost directory is called /. You can navigate around the file system, moving into or out of the directories and listing the contents of the directory you're currently in. This isn't going to be like an interactive thing, is it? Within the terminal output, lines begin with $, are commands you execute. Oh. Okay, so our puzzle, this is the puzzle input. Or this is the test input. Okay. Sorry, I'm a little slow this morning. CD means change directory. CDX means move in one level. So CDD, move to directory D. How do you know directory D is there? I guess you would have seen it. There it is, dir D. Oops. That's right, triple click means select the whole thing. CD ... means move out one level. It finds the directory that contains the current directory and makes that directory the current directory. And CD/ means switches the current directory to the outermost directory /. LS means list. Prints out all the files and directories immediately contained by the current directory. 123 ABC means the current directory contains a file named ABC with size 123. dir XYZ means that the current directory contains the directory named XYZ. Okay. It's a little awkward, but it makes it very easy to parse, right? You don't have to deal with the little the D in front of something. Like if I say ls-l here, right? This means it's a directory, and this is the size. So we don't have to worry about all of that. We can just get this stuff we need. Actually, what do we need? Given the commands in the output and example above, you can determine the file system looks visually like this. Okay, here there are 4 directories. A, E, and D. Oh, and /. Right, that's another directory. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. All right. Total size of directories is the sum of the sizes of the files it contains directly or indirectly. Directories themselves do not count as having any intrinsic size. The total size of the directory above can be found as follows. Okay, now I think I understand. So it's basically, if you're trying to find the size of A, you add up the size of E plus F plus G plus H. And E contains I, which has 584. I think I understand all that. Okay. To begin, find out all the directories, the total size of at most, that's 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E. Directory A has 94853. Directory D has this much. Find all the directories with the total size of at most 100,000. What is the sum of the total sizes of those directories? Okay, let's get the input and take a look at it. 2022, day 7. Oh, right. Dang it. Okay, let me do this real quick. Let me do that over here. 2022-07. All right, so what I did was I changed my get input thing so it gets the input, it adds it, it commits it, and then it shows the first few lines and says how many lines it read. So you can kind of get a sense of what the file looks like. For those files that have a single line of 1,000,000 characters, that's going to be a little annoying, but we'll cross that bridge when we blow it up. All right, so it's got 1,005 lines, and it just looks like the basic puzzle input. What I would like to do for this one, though, is temporarily create a test input, because this might be a little more complicated. Rust has issues with trees and parent pointers, and so this is going to be a little more fiddly than the usual puzzle. Okay, we can do it. In Vim mod. Okay, we're going to create the module for day 7. F6 R7. And mod day 07. Try to build it. Create it. Jump to it. Oops, I messed something up. We'll fix that in a second. 2207. And then we'll flip back here. Oh, no, it worked. Okay, I didn't mess something up. I was mistaken that I made a mistake. Okay, so I think the first thing I'd like to do, I'm trying to think of the best way to do it. We can create a directory structure, right? We can say struct dir. Directories have names, and they have sizes. Because I don't think, here's the reason I'm going with size on the directory itself, is that right now it's not, at least for now, maybe that'll change for part 2, but for now it's not asking for the file names. Right? It doesn't care what the file names are. It only cares about the total size. So I'm thinking that as I parse through the commands, I'll just throw the size of the directory into the size value. It'll just be a usize. And then a parent should be an option. Oh, right. Okay, so this is where we get tricky, because we need to do RCs so that we can have multiple standard collection, standard RC, RC. And that way we can have multiple references, because we're also going to need a list of all the directory names and a directory reference to that. Right, so this is going to be subdir, and we'll just call it, it's just going to be a hash map with a name to a directory, like that. I think that'll work. If I say I think a few more times, maybe it really will work. Collections hash map. So I didn't want standard collections after all, didn't I? All right, that should at least compile. Yeah, it's just saying that doesn't exist. All right, so we should be able to now, I think, build up. So actually what we can do here is just say this is our root, which is going to be a directory. And that should, the trait default is not set for dir, so what we can do is do that, right? And that should work. Right, now we can just create a default directory, and we're not using anything yet. That's fine. All right, so now to build up the root directory, we have self. So self.root is our directory. So we want to set our current directory. So I think what's going to happen is as we execute these commands, and I'm going to use the test input for now. So for line in AOC lib read lines test input dot text, and I'll just say println. No, we don't have to do that yet. What we can do is split out line dot split each word by space. right? And that should do it. Now we just need to look. So if the first character is a $sign, then we know it's going to be a command. If it's a dir, we know it's going to be a directory, and we can stick it in our hash. If it's a size, we just add it to the current size. And if it's ls, we can ignore it, I guess, because we don't care that there's an ls command. What we can do, let's do this. Let's do it this way. Match words of 0, words of 1. So now we have a tuple that we can match against to take a look at what's going on. And if we have a tuple with $ls, we don't care, right? That's a do nothing, no op. If it's a $cd, then we have to do some fun stuff. We need a current directory. Let cwd is equal to rc clone self root. Just temporarily here, I'm just going to do this and say to do. I just wanted to get it to build so I can see if this is at least on the right track. Oh, right. These need to be double quotes. I don't know what I was thinking. Nope. There. This needs to be an ampersand. Okay, good. So it's building. So CD is going to be a little special, right? Because we can either do /, which means go back to the root. We could go to a directory, which means that's our new directory. Or it's going to be a ... which means we want to grab the parent, which we have as an option rcdir. Okay, so we can just do that as one at a time. If words of 2, we can do a match. Match words of 2. If it's a /, then use back to rc clone self root. Oops, comma. If it's ... then the current working directory is going to be rc clone cwd.parent.unwrap. And then anything else, we're going to create a new directory. The new directory is going to be, I'm going to assume that we've already gone through the ls and put all the dirs into our hash map, right? So it'll be in the hash map. So we should be able to say cd subdir.get words. Actually, let's call it dir name. Dir name, unwrap. And then cwd is, and what is this? Oops. What is this? This is a nothing? No information available? Yes, that works. That works. Why doesn't this work? It's a hash map. All right. Well, I guess we have to ask the compiler to tell me what's wrong. Oh, I have a mismatched thing here. That's what's wrong. Okay. Oh, wait, there is a bug. Oh, right. Yeah, we ran into this problem in previous days as ref. There we go. So new dir should be an RC dir, and then we should be able to say, I'm doing it in 2 steps because I don't think you can do it in 1, but let's find out. Clone. And that would clone the reference. Oh, I'd like that. Okay. Can we do it without the braces? Nice. Okay, so that's pretty clean. So that's CD done. Next, we want to look at dir, right? So we have, let's just pull up the text again. So it's dir and then the name. So dir name. So now we need to insert into the hash map cwd.subdir.insert dir name. Oh, I've called it a string, right? And this is a stir, so to string. And we have to create a new directory object, rc new dir name is dir name toString. Let's do this in, there we go, that looks better. Size is going to start off as 0. The parent is going to be some rc clone of cwd, and then the subdir is just going to be a hash set new, a hash map, sorry, new. And that's that, come on. And then that's the insert, and that's the whole thing. In formats, will it build? It will not. Okay, so we can ampersand that. And what's this complaining about? Oh, the match doesn't all match. This has a unit type, and this has unit type, but this insert returns something. So we have to throw away the return value by doing that. Except it doesn't like that. Maybe because of the comma. I'm missing a closing bracket, but I just closed it right here. That's that one. That's that one. That's the insert. Ah, I must have deleted it for somehow. Oh, this thing here came out of nowhere. Okay, that's what the problem was. Cannot borrow is mutable. You know what that means? That means we have to pull out the heavy guns here. Use standard cell, ref cell. And we're going to make this a ref cell hash map. And that'll allow us to borrow it as mutable. We have to change the creation here. Ref cell new. Subdir borrow mute. Okay. Method not found. Oh, borrow. Still fits on one line. Okay. And now we have a problem here. Yeah, okay, so my first instinct was right to create it as 2 steps. Okay. I should have paid attention to my instincts. So what we need to do is create let new dir is equal to this bit, this kind of mess. Right? Semicolon, and then just say this is equal to rc clone new dir, I think. We might be able to say this. Let's find out. Yeah. Okay, so we don't have to clone it. And now it's building again. But we haven't implemented one part of it yet. So let's implement this final part, which is the size followed by a name. This Christmas music is really getting to me right now. I don't know why I chose it. Okay. And for this, we just need to, oh, you know what? If we couldn't do the ref cell, we couldn't do the non-ref cell hash map, we can't do a non-ref cell size. So ref cell, well, let me prove it first. cwd.size plus equals size. Oh, size dot parse unwrap. Can't infer the type, but CWD size is a U size, and you know you're adding it to. All right, Rust. Why you got to be like that? Yeah. So now we can't assign that. Okay, so we'll just do it the ref cell way. Ref cell size. And we just say dot borrow mute. Right? Oh, ref cell new. And this doesn't work because I didn't put an asterisk in front of it. There we go. We're not using the name anywhere. Not yet, I guess, but maybe later. All right, you know what I'll do for now, just to make it not complain. But it looks like it's parsing everything, which is good. Okay. I can't print it out. Like if I derived debug for this and then tried to debug out the thing, it would fail because this is pointing back to the parent. And so it will always keep doing that. And it'll just recurse infinitely. So I can't really print out what we got. So what are we doing? I forgot what we were doing. All right. Find all of the directories with the total size of at most 100,000. Okay. Here's what I'm going to do then. Since this is recursive, let's write a recursive function to calculate the size. Simple dir. We'll just call it getSize and return a uSize. And it should be very straightforward because it's whatever the current size is, self-size borrow. Right? Oh, it won't tell me the type. But I think it's that, yeah, self-size borrow should just be a uSize. Plus, and now we just want to loop over the subdirectory. So self sub dir borrow. And we only care about the values. We don't care about the name of the subdirectory. We only care about the values of the subdirectory. So we can just say values. And then we'll take each value and add them up. So A, B. B is a directory. A is on I32. Really? Maybe it'll change once I do this. I'll say A plus B dot get size. Yeah, now it's a uSize. And that's all we have to do to get the size of a directory. Right? As soon as I do that. Okay. So with that helper function, we should be able to just visit from the top every directory, add up its size. We could memoize it. We could stick in here a subdirectory size. But let's cross that bridge if we need to. So let's just use our usual stack pattern. That'll be RC clone of self root. Right, so that'll be the first thing we visit, and we can say while let sum dir is equal to visit dot pop, and then we want to push all of the directories on that we have. So we can say for d in dir dot subdir borrow values. And these should be RC dirs. So we could just say to visit dot push d dot clone. Or RC clone d. Whichever. Okay. And then we just need to get the size. So we can say, and we have to check to see if it's less than 100,000. So we can say let size is equal to d.dir dot get size. If size is less than 100,000, let me just copy paste because, oh, it says at most 100,000. So less than or equal to. Then we're going to have a total. And just add it in. Total plus equals size. And then the output is total. Should we try it? 954. Oh, we don't want to try it because that's this. Okay. (95437) 95437. Okay. So we were successful with the test input. Let's try the real input. I almost made a mistake there. Input / 2022-07.text. The real number is this thing. All right, let's see if that's right. Ta-da! Okay. Let's check in with Clippy real quick before we commit these changes. This expression contains a reference, which is immediately dereferenced, so we don't need the reference in there. Boom. Done. Okay, that was the only thing. Yeah, that seems pretty straightforward. We don't care about ls commands. cd change the current working directory, and we had to break this up into 2 different steps. Creating a new directory was basically putting the name, or putting in a hash map the name. And the reason I did it in a hash map was so that this worked. Right? We could just go to any directory we want just by looking up the name in the hash map. And for such a tiny file system, that's not too bad. We can store the entire hash map in memory. All right, git status, git add source, git commit. I'm going to leave test input there for now. 2022, day 7, part 1, in case we need it for part 2. There we go. Part 1 done. Let's take a look at part 2. And now you're ready to choose a directory to delete. Okay, the total disk space available to the file system is this number, 70 million? Okay. To run the update, you need unused space of at least 30 million. You need to find a directory you can delete that will free up enough space to run the update. That makes sense. In the example above, the total size of the outermost directory, and thus the total amount of used space, is whatever. This means that the size of the unused space must currently be this, which isn't quite the 30 million required by the update. Therefore, the update still requires a directory with the total size of at least this to be deleted before it can run. To choose this, you have the following options. Delete directory E, that wouldn't free enough space. A, D, or the root. That would definitely free up enough space. Directories E and A are both too small. Deleting them would not free up enough space. However, directories D and root are both big enough. Between these, choose the smallest, D, increasing unused space by this amount. Find the smallest directory that, if deleted, would free up enough space on the file system to run the update. What is the total size of that directory? Okay. It's basically we do the same work except calculate a different number for part 2. What we can do is say, we'll do it in step at a time. So let total size is equal to self.root.getSize. And I'm just going to print that out. And we can take a look at what that number looks like. It's a big number. The next number we need to calculate is how much free space there is. Let free space is equal to the amount it could have been if there were nothing in there minus the total size. And we can print that out. So it's this number. Next, we need to find out how much space we need to free. Space needed is equal to this number, copy, paste, minus the free space. So one step at a time here, make sure we get this right. So this is how much space we need to free. So we need to find a directory that's at least this big. And we want to find the smallest directory that's at least that big. Okay. So it's basically the same code, except instead of checking to see if size is less than, we're going to have a best here. Best is going to be equal to, it's going to be a min. So we need max, usize max. But it's going to be a min on the amount we need. So we need at least as much as space needed. And instead of adding it up, we'll say best is equal to best dot min size. Right? Because all we care about is the size. We don't care about the file name. So we didn't need to store those anywhere. And so now we just output the best. All right, fingers crossed. Is this the best number I can submit? Ta-da! Perfect. Okay. Day 7 done. Let's check Clippy. What else? What can we do here, though? Because I think we could do this in a different way. We don't need to do it like this. I think we can do it just using extend onto visit. And we can just say dir subdir borrow. But then I don't think this works as values. It might not be the right type. Yeah, it's not the right type. What do I need to do here? Oh, it found a reference, but it was looking for RC. So I think I have to say map d dot, no, RC clone d. Help replace the closure with the function itself. Okay. Oh, that's right. You can do that with and now I have an unclosed delimiter again, because I keep doing that. Oh, just the, right. There we go. Okay. Does it give me the same number, though? It should be 21047. Yep. Okay. So we can just replace this one down here also. Right there. And that should give us the 5883165. Good. All right. Yeah, that's a little bit cleaner. We probably could also, oh no, because we have to check. I can't just say the min on it because it has to be a min of at least. And I don't know how to do that in a single statement. And same with here. If size is greater than 100,000, you can't really. All right. I don't know if there's a cleaner way to do that. But I like this. Right? We're just adding all the directories we need to look in, and then we just keep going until we find all the directories. And anything that's less than 100,000, we just add in. That's part 1. And part 2, anything that's bigger than the amount of space we need. Now this we could reduce to a single statement, but I think this is pretty clean in terms of understanding if somebody's reading the code. So I'm going to leave it like that. And then we have this little helper function here, which gets the size of a directory plus all of its subdirectories using recursion. Sweet. I can remove test input now. Git commit -am 2022 day 7 part 2. All right. Should we go to 2017? I have time.